Super speed is awesome. I can dodge bullets. Boop! I can punch so quickly that my fists acquire near infinite mass. And I can travel to any place in the universe in a flash. Do you know where I just was? I was in Italy, touching a spaghetti. But this is the idealized version of super speed, one that ignores the consequences of gotta go fast. Realistically speaking, if you are suddenly given the ability to make the suddenest of movements, I don't think that you'd want this power. I forgot my markers in Italy. Now, before we begin, I want to be very clear. Like my episode about not wanting super strength, I'm not saying that any increase in speed would be bad or unwanted. Just imagine if humans could run 160 kilometers or 100 miles per hour. That would probably be awesome. It wouldn't have too many unfortunate consequences. No, the kind of speed that I'm talking about is the kind of speed that lets heroes markers! The kind of speed that lets heroes outrun instantaneousness itself, like the Flash did in The Human Race. This is pop culture's version of super speed. And what I am saying is that without any other superpowers to protect you, this kind of speed would not be dope, but disastrous, as I will now explore with you after I get this marinara off my shirt! Now, humans, though we be squishy things, already can and do travel at incredible velocities without issue. For example, astronauts inside of the International Space Station have an orbital velocity of 7 kilometers per second. They see 15 to 16 sunrises a day. So absolute velocity isn't the problem. What is the problem, the first problem with comic book style super speed, is super acceleration, how velocity changes over time. If the astronauts in the ISS went from 0 to 7 kilometers per second in an instant, inside of that space station it would look like marinara sauce. Just a sec, I gotta go somewhere. The most common unit that you'll see for acceleration or deceleration is the G, which references how quickly things fall towards the center of the Earth because of the Earth's mass and radius. Now, because of the Earth's specific mass and radius, objects in free fall will get 9.81 meters per second added to their velocity for every second that they are falling. Now, accelerate or decelerate twice as fast as this value, and that's 2g. Now again, though humans be squishy things, we can handle a decent amount of g's. Things don't really get dangerous until you're pulling around 100 or more. If you want the math, pulling 100 g's is like going from highway speeds to a dead stop in just this amount of distance, 1/3 of a meter or a single foot. Now imagine how many G's speedsters must be pulling in pop culture to do what we see them do. Speedsters like the Flash are fast, duh, but they also go fast very fastly. Super acceleration. For example, let's say that the Flash gets up to a jogging pace of 1/10 the speed of light, 0.1 c, and he does so in the blink of an eye, maybe 1/10 of a second. We know that this is doable for him in the comics, but for you to do the same, to achieve the same rate of acceleration, you would have to pull 30 million G's to get to the same speed that quickly. Now, if you multiply this value times an average mass for a human person, that means your legs, to get to this value, would have to generate over 20 billion newtons of force. 1,000 times more force than the space shuttle taking off. So, without any other speed, force, or superpower to protect you, this is the acceleration problem. If you tried to instantly get up to super speed, your legs would snap! Oh! Or if you tried to save anyone by bringing them up to your crazy speed, you would end up just ripping a limb off, my pasta-eating arm. Extreme acceleration wouldn't just be a problem for your limbs. Your brain would have to accelerate too, not like that. The speed of you won't matter very much if your speed of thought doesn't match. In my very first episode of this show, where I look like Justin Bieber's unfamous brother, I explained that human perception isn't really evolved to handle flash-like velocities. So let's say, for example, I threw something past your field of vision, the speed of a rifle bullet, maybe 1,200 meters per second. I don't know, let's say a plate of spaghetti. Now, because of how human perception functions, when I throw this, it's going to be necessarily blurry if you really register its motion at all. So, therefore, if you move at flash-like velocities, the entire world is going to be necessarily and dangerously blurry. There is a fascinating real-world example of this speed versus speed of perception problem, and it's currently skittering around the world's sands and lakeshores. The tiger beetle. These little beetles are the flashes of the insect world. The fastest among them can cover 125 body lengths in just a single second. Scale this up to human size, and that's like running at 770 kilometers or 480 miles per hour. Now, the tiger beetle has evolved incredible speed, and it makes them ferocious predators, but because they don't have the visual perception to match, they are functionally blind as they run. Tiger beetles are so fast that when they run after prey, the world blurs around them, and so they have to stop and start, or else they miss their prey or just bump into stuff. This little beetle proves that without some kind of enhanced perception added to your super speed, you would probably have to stop and start as well. And let's admit, this is kinda lame.
Hit. Huh. Huh.
To be fair, comics like The Flash have acknowledged this perception problem. For example, in Superman number 709, The Flash says that he can think at the speed of light and perceive events that occur on the order of attoseconds. With perception like this, not only could The Flash see, I don't know, a plate of spaghetti moving towards him at 1,200 meters per second, he could see its molecules vibrate. This kind of perception is like being able to take a single second in your mind and stretch it out to 31 billion years. And without perception like this, your world is going to be a blur if you try to move with super speed, and it's going to be your doom. Your tasty doom. But let's say that you can perceive things that are normally imperceptible and that your legs are unsnappable. You still have the biggest problem with super speed. You can't use it anywhere. What happens when an object from space enters Earth's atmosphere? Why does it heat up and eventually burn up and destroy itself? Well, it's a common assumption that friction has something to do with it, but it's actually something called adiabatic compression. Adiabatic meaning no heat is leaving the system that you are compressing. And I say heat because if you compress a gas without letting it expand in that volume, it heats up. You're putting energy into a now smaller system. And you can test this principle at home with just a bicycle pump. If you pump it up, and then touch that pump, it's going to be warm. This is the same thing that happens to objects when they enter Earth's atmosphere. Because they are going so fast, typically they compress a plug of air directly in front of them adiabatically, just like a bike pump, which heats up the air, which heats up the object, which destroys the object. By the same reasoning, if you had super speed and you were just running through the atmosphere, let's say a city, you would heat up like a meteorite and eventually burn up and vaporize yourself. But first, your clothes would fly off, which would be so embarrassing. If the heat doesn't get you, the bugs will. Let's say that you have super speed and you take off running at Mach 1, 343 meters per second. Insects are everywhere. If you even hit a housefly at this velocity, The impact would impart 58 newtons of force on you, about 13 pounds of force, which isn't all that much, but again, we're not going all that fast yet. What if we took off running at 1/10 the speed of light like the Flash could? Hit just a housefly at this velocity and it would impart over 450 billion newtons of force to you. The pressure of this is like having all of the water behind Hoover Dam press on you across the surface area of a tiny fly's face. What I am getting at here is that if you attempt to run anywhere on Earth, something is going to immediately turn you into Swiss cheese, which is not as good as mozzarella cheese. Just a sec, I have to go to not Italy. The fact of the matter is, you can't escape being obliterated by debris at super speeds anywhere, not even in space. In space, inside 1 cubic centimeter of volume, you will find on average a single atom. Now, this is nowhere near the particle density that would heat you up and vaporize you if you're running at super speed through an atmosphere, but just a single atom in this amount of volume is too much. If a super speedster actually ran through empty space at or near light speed, as we've seen them do in the comics and pop culture before, then, as physicist William Edelstein at Johns Hopkins University calculated for the perils of light speed spacecraft travel, they would receive a fatal dose of radiation just in the form of the lonely particles they'd be hitting in a single second. Running through empty space, let alone an atmosphere, would be like sticking your head in the Large Hadron Collider, but worse. And so I don't think you really want super speed. Like super strength, it doesn't work without other superpowers in place that would have to protect you. If you tried to zip around a city as a hero, you'd end up, realistically speaking, a shattered, naked, burning, confused mess. You wouldn't even be able to use super speed in space, where there's nothing. What I think you might want, though, is that super perception that would have to go along with super speed. Imagine being able to extend seconds of time into billions of years in your mind, relatively speaking. You could come up with the perfect reply to any question. You could notice literally everything. You could stare at pasta. And in general, you could live life on delay. Another kind of super speed. Because science. Wait, apply what you learned. Be safe. Again, to be fair, the Flash, specifically, appreciates science more than most. They will talk about the physics of moving that fast. They will talk about relativity and infinite mass punch with relativistic mass. And specifically in that Human Race comic that I mentioned, the Flash zooms with super speed at near instantaneous speed. And he goes up to his girlfriend, who he loves, and he's just looking at her like, wow, I'd love to kiss her right now. But I'm going so fast that if I kissed her, she'd explode. And I appreciate that. Thank you so much for watching, Ian. If you like this video, consider liking and subscribing. And if you're on YouTube, hitting that notification bell, ding. And if you want more of me, check out Musquatch on Nerdist.com or go to ProjectAlpha.com and you can sign up to get this show 2 days earlier than everyone else and other premium stuff. And you can follow Because Science here at these handles and me also at those handles. Thanks again.